Okay, today we're going to talk about a property of substances. We're getting ready to go into Chapter 15. And Chapter 15 deals with energy of chemical reactions. Every chemical reaction, heat is either gained or heat is released. If it gets hot, that means heat is being released. It's exothermic. If it gets cool, it means heat is being absorbed, and it's endothermic. But every chemical reaction, there is a change in heat energy. This chapter deals with that. Heat also is a property of substances. So not dealing with chemical reaction, but of substances. Just like boiling, water boils at 100 degrees Celsius. Water freezes at 0. Water melts at 0. Water has a density of 1. None of that has anything to do with a chemical reaction. It's just a property of a substance. So to get started here, we're going to talk about a property of substances that has something to do with heat. And that is called specific heat. So as you see on the board, specific heat, my definition, or not really my definition, but a scientific definition, is the amount of heat required to raise 1 gram of a substance by 1 degree Celsius. The amount of heat required to raise 1 gram of a substance by 1 degree Celsius. So if we take a gram of a substance and we raise the temperature by 1 degree, the amount of heat that it takes to do that is referred to as the specific heat of that substance. It is a property. It is something that can be used to identify an unknown, and it's something that doesn't change for a given substance. Specific heat has a chemical, not a chemical formula, a mathematical equation of specific heat is equal to the heat that could be either absorbed or released, either way, divided by the mass of the substance times the change in temperature. Now, there's some things I need to tell you about these 4 unknowns here: specific heat, heat, mass, and change in temperature. Specific heat, first of all, has a symbol or abbreviation that is used as a C. So when we kind of modify this equation and simplify it a little bit, we're going to use the symbol C. Specific heat is C. The heat, the unit for heat, there's 2 common units for heat. The first one is the calorie, C-O-L-O-R-I-E, and the abbreviation is little c, little a, little l. And that is something that you guys are kind of familiar with probably, because when you buy a candy bar, you sometimes look and see that you've eaten 400 calories of energy. And then that means you would have to go work out and burn off 400 calories of energy to break even, so you don't gain weight. Another unit that's also used for heat is the joule, J-O-U-L-E, has a symbol of a J, and those are just 2 common units, just like we can measure things in inches or in centimeters. Mass for specific heat is typically done in grams, which has a symbol of a G. And change in temperature, the temperature is in degrees Celsius. So when we go to calculate, you may ask, what is a unit for specific heat, the entire unit? If we calculate heat in calories, mass in grams, temperature in degrees Celsius, then the unit for specific heat in that scenario would be calories per gram times degrees Celsius, or we just say gram degrees Celsius. So if your heat was in calories, then your unit's calories over gram degrees Celsius, because calories over gram degrees Celsius. If your heat was in joules, then it's joules per gram degrees Celsius. So that would be your units for specific heat. So as you can see, we're going to have four variables. First of all, I guess the simplified version would be C is equal to Q, where Q is the abbreviation, the symbol that's used for heat, not really abbreviation, but a symbol, divided by M for mass times change in temperature. So that is your abbreviated, your simplified mathematical equation for specific heat. There's two specific heats I do want you to learn and to remember, and that is for water, since water is very common. The specific heat for water is 1 calorie per gram degree Celsius. It means it takes 1 calorie of heat to raise 1 gram of water 1 degree Celsius. In joules, that is 4.184 joules per gram degree Celsius. So you're going to have some homework questions out of the book that I'm going to assign you here shortly. And it's basically I'm going to give you 3 of these variables and ask you to solve for the unknown. So let's do a problem here. Let's say that you have a block of some sort of substance, and you weigh that substance, and let's just say that substance weighs 27.4 grams, and you take that substance at 10 degrees Celsius. You've got it in some sort of controlled environment where it's 10 degrees, and you heat it up to 70 degrees Celsius. So it goes from 10 to 70. And you somehow can determine, which we will get into this later when we talk about calorimetry, but you somehow determine that that substance has gained 4,308 joules of energy. So my question is, what is the specific heat for this substance? As most of you can probably tell, we are going to use the specific heat formula. Specific heat is equal to the heat divided by the mass times change in temperature. Specific heat is equal to the heat, in this case that was absorbed, 4,308 calories. And we know that was absorbed because it got hotter, divided by the mass, which is 27.4 grams, times the change in temperature, that was 60. So we're solving for specific heat. So if we would take 4,308 divided by 27.4 times 60 in parentheses, you get a specific heat of 2.620, and the unit for that, since this was in joules and this was in grams and this is in degrees Celsius, the unit would be joules per gram degree Celsius for this substance. So I could give you any of the 3 variables and ask you to solve for the unknown. And that is specific heat. We have tables of specific heat for all kinds of substances in the chemistry of handbook and physics. So that is that.